Hello students and welcome back to my channel. We are discussing questions which were asked on 31st of January 2023 JEE mains, both the shifts combined. This is the last video of that sequel, student. Rest all the questions have already been discussed. You can check. Coming to question 57. The effect of increase in temperature on number of electrons in the conduction band and resistance of the semiconductor. As we all know that when we increase the temperature, basically we are imparting more heat energy to the substance. So all the electrons present in the valence band will be able to absorb this heat energy and they'll be moving on to the conduction band by overcoming the energy difference which is known as the energy gap. So naturally, when we increase the temperature, number of electrons in the electron conduction band will increase. More and more electrons from the valence band will be able to overcome the energy gap and they will be reaching the conduction band. So that is one thing. Now, resistance of semiconductors, unlike resistance of semiconductors, they depend on the number of charge carriers. More the number of charge carriers, lesser will be the resistance or more will be the conductance. So here what happens, as we increase the temperature, the number of electrons in the conduction band increases. So number of electrons in the conduction band are one of the charge carriers and the number of holes in the valence band are also the charge carriers. So here since charge carriers increase, so the conductance will increase and resistance will decrease. So D option is the correct option. Any increases and resistance decreases. Coming to question 58. The amplitude of this much is modulated by this signal. The amplitude modulated signal contains frequencies of. Now you see this is 2 pi f omega coefficient of t. So frequency is 500 hertz. Similarly 2 pi f is 4 pi. So here frequency is 2 hertz. This is frequency of the this is the frequency of carrier wave. This is the frequency of modulating wave. Now we know in the spectrum, amplitude spectrum, you will find that there is a frequency equal to carrier wave frequency. Then there is a frequency equal to carrier wave frequency minus frequency of modulating wave. And there will be a frequency equal to Fc plus Fm. So these will be the three frequencies which will be present in the modulated wave. Of course, before what you call broadcasting, this is eliminated. Of course, this frequency signal is eliminated. So here Fc is 500. So we have 500 minus 2, that is 498, and this is 500 plus 2, that is 502. So 498 will be there, 502 will be there. So A, D and E, that is D option is the correct answer. Then moving on to the next question, given below are two statements. For transmitting a signal, size of antenna should be comparable to wavelength lambda of signal. That is true, students. We have basically two types of, broadly classifying, we have basically two types of antenna. One is the Marconian antenna and the other is Hertz antenna or Hertzian antenna. So this is the concept of Marconian antenna. Okay, 1/4 of the lambda is buried inside the earth. Only 1/4 lambda is outside the earth. Then you have Hertzian antenna where you have lambda by 2 on either side. In amplitude modulation, amplitude of carrier wave remains constant. This is absolutely wrong, students, because amplitude modulation means the amplitude has to change. The variation in amplitude of the carrier wave will be in accordance with the modulating wave. In case of amplitude modulated wave, in case of frequency modulated wave, the frequency of the carrier wave variation will be in accordance with that of the modulating wave. So here amplitude modulation itself means amplitude has to change. Amplitude of the carrier wave has to change. Statement 1 is true. 2 is wrong. C option. Statement 1 is correct, but statement 2 is incorrect. Then moving to the next question. In a typical transistor, all three regions, emitter, base, and collector, have same doping level. This is wrong, student. All the three regions do not have the same doping level, unfortunately. Okay? Because emitter has the highest doping ratio. Emitter has the highest doping ratio, base has the lowest doping ratio, and collector has medium level doping ratio. That is how they are made to work, because their basic functioning is dependent on their doping also. If doping is not proper, then their functioning will also be not proper. Then statement 2, in a transistor, collector is the thickest and base is the thinnest. This is correct, student. Again, this is how they work, how they are made to work. Okay. So statement 1 is wrong, 2 is correct. Statement 1 is incorrect, but 2 is. So B option is the correct option. That's all, students, in this video. Thank you so much for watching my channel.